Hello, fabulous mathematicians. Today we are going to study commutativity to find the known facts of 6, 7, 8, and 9. You will need your sharpened pencil with an eraser, your guided note sheet, and you'll follow along and fill in the spaces as I tell you to in the video, and of course your multiplication table. So let's review. I know we've spoken about this already, but the commutative property is a mathematical property. It states that order does not matter in multiplication or addition. So for example, 3 plus 2 is 5, and 2 plus 3 is 5. Also with multiplication, 4 times 2 is 8, and 2 times 4 is 8. Please raise a quiet hand if you have any questions about this or if you disagree, and we will talk through it as a class. All right, so now we're going to continue to review. Stand next to your desk, put your arms out so you can make sure that you're not touching your neighbor, and we are going to prepare to do some jumping jacks and practice our math facts. Let's start by counting in multiples of 1.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Let's count by multiples of 2.
2, 4, 6, 8, 10, 12, 14, 16, 18, 20.
Let's count by multiples of 3.
3, 6, 9, 12, 15, 18, 21, 24, 27, 30.
Let's count by multiples of 4.
4, 8, 12, 16, 20, 24, 28, 32, 36, 40.
Let's count by multiples of 5.
5, 10, 15, 20, 25, 30, 35, 40, 45, 50.
Let's count by multiples of 10.
10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Deep breath in, deep breath out. Great job!
That was a lot of fun. Problem 1A on your problem set shows a multiplication chart. The shaded numbers along the left column and the top are factors. The numbers inside the chart are products. Each unshaded box represents or stands for the product of one multiplication fact. Find the total number of facts on your multiplication chart. I'll give you a moment to do that. How many factors are on the chart? Okay, you should have gotten the number 100 facts. So let's use the chart to locate the product of 3 and 6. Put your finger on the row labeled 3. Okay, and slide it to the right until it's also in the column labeled 6. And there you have it. The number in the square where the row and the column meet is the product, which has already been done for you. So using the chart, what is the product of 3 and 6? You should have the number 18. So now let's locate the product of 6 and 3. So we know that we can look here, and there's 6. So if we slide our finger over to where the 6 and the 3 meet, Sometimes it helps to put one finger on the 3 and one finger on the 6 until they meet. And we'll find we know that 3 times 6, that we already did, equals 18. So because we know the commutative property states that it's the same answer in reverse, we know that 6 times 3 is also 18. So go ahead and write an 18 in there. Good job. So we know that we can use commutativity to solve many new facts and fill in the products on the chart. On the chart, write the products for all the facts that we've already studied. Then fill in those that you can solve using commutativity. I already know my multiplication facts for the number 1. I know 5 times 1 equals 5, 6 times 1 equals 6, 7 times 1 equals 7, and so forth. So take a few minutes and do that yourself. And it's the same because of commutativity. We know that we can do that in the rows and the columns. Good. If you have any troubles whatsoever, raise a quiet hand and someone will be ready to assist you. And 18's already there for me. If you need any help, just remember the commutativity. You can look at other facts, and the 18 is already here for you. Okay, and we remembered 4 times 1 is 4. 4 times 2 is 8. And everyone I know is awesome at counting by 5s. We did this when we were telling time in the last unit. So just as you would, 5, 10, 15. If you still aren't here, raise a quiet hand and the video will be paused for you. Now we haven't done our factors of 6, 7, 8, or 9 yet, but we know because of commutativity that we can go this way as well. So 2, 4, 6, 8, 10, 12, and keep going. And remember, we have 3. So here's our 18. Remember, we did this already. And your handwriting is going to be a lot better than mine on this tablet. I still need lots of practice. But that's okay. Remember, 4. We're going to keep going because we know that commutativity says, for example, we don't know, we haven't learned our multiplication facts for 6 yet. 6 times 4. But we definitely know that 4 times 6 is 24. So keep on going. Okay, good. We have our multiplication facts for 5s. Okay, so everybody should be doing really well now. Okay, so we haven't learned our multiplication facts for 6, 7, 8, or 9 yet, but we do know 10s. 10, 20, 30, 40, 50. Nice. Okay, so we know that we have all of those. Let's go ahead and shade those in. So I'm not going to shade over this because I don't want everything to disappear. But you can shade all of the ones that you have so far and just with a light pencil, just to show that these are the multiplication facts that you already know. So let's see how many we need to do. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. But look, we still know this because of commutativity. So let's go ahead and finish this too. There we go. Good. So now we only have these. Count how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We also could have looked, and this is kind of like an array, isn't it? We could have said 1, 2, 3, 4. Okay, I know I have 4 there, multiplied by 1, 2, 3, 4. So 4 times 4. Well, I know that 4 times 4 equals 16. So you could be a smarty pants and use that one instead of counting. We can use commutativity to solve many new facts and fill in the products on the chart. Yes, there are 12 facts that we can use the commutative property to solve. That means we only need to know 6 of them. Really, there are only 10 new facts to learn before you know all the facts up to 10 times 10. I am going to go ahead and complete this multiplication chart. Go ahead and fill this in. All right. The multiplication fact chart is completed. Take a moment to go ahead and complete this. Okay, now we have a problem that we're going to work on. Each bag contains 7 apples. We are tasked with completing the chart. If we have 2 groups of 7 or 2 bags of apples, we can also say 2 times 7. This is a multiplication fact that you should already know. Therefore, the answer should be 14. If you have a question about this, please raise a quiet hand. But now we know that we have a blank space here that we need to fill in. the number of bags. So there are 7 apples in each bag. But how many bags do I need to have 21 apples? Well, we could do this one of 2 ways. We could say, we could use the variable. We talked about variables last week. That just means any unknown number. We could say the variable a for apple multiplied by 7 for 7 apples is equal to 21. And then we would know that the number of apples is equal to 3 because 7 times 3 or 3 times 7 equals 21. Okay, that makes sense. All right, so we know that 3 times 7 and 7 times 3 both equal 21. But since we already have our 7, we are going to put a 3 here. We already know our math facts. So 4 times 7 is 28. If you need to reference your multiplication chart, that's fine too. 5 times 7 equals 35. Finally, try to do the last one on your own. I'll give you a few moments. You could ask yourself, a times 7 is equal to 42. What number do you multiply by 7 to get 42? Look at your multiplication chart, or maybe you already know. The answer should be 6. Give yourself a pat on the back. Let's try another one. Use the array to write 2 different multiplication sentences. Now, a lot of students get scared because the equal sign is on the opposite side. You have an equal sign here. That's okay. It's still the same problem, and you don't have to be afraid. So let's do this. Let's count. 1, 2, 3, 4. So we could say 4 times 1, 2, 3, 4, 5, 6. 4 times 6. Great. We know our multiplication facts, so we know that 4 times 6 equals 24. All right, so commutativity states that 4 and 6 can be switched and it's still the same. So we could say 6 times 4. What do you think the answer is going to be? Well, I know because I am familiar with the commutative property of multiplication and addition, and I know that this is multiplication, so I'm saying to myself, I know that those can be switched and the answer is still the same. So I know that the answer will be 24. That wasn't too bad. Okay. 2 7s is the same as saying 2 times 7. So I could just say here, for my reference, 2 times 7. Well, I know because of the property of the commutative property that 2 times 7 is the same as 7 times 2. And I know that this is written in word, a number word. So I'm going to say 7. I'm actually going to write the word 7 instead of just putting the number 7. And we know that that is correct because 2 times 7 does equal 14, and 7 times 2, of course, also equals 14. Raise a quiet hand if you have any questions about that. Now, this next one seems tricky in the beginning. It seems like it would be a really difficult problem, but if you look closely, you'll find that it's actually very easy. Sometimes math problems look difficult, and it's important to make sure that we don't get scared and we don't get upset, but that we keep pushing and we raise a quiet hand if we have any questions and we figure it out, because you are very, very intelligent mathematicians, and I know that you can do this. Okay, so let's look at the first part. 3 times 9. Well, we know our math facts, and we know that 3 times 9 is in fact 27. That's something that we know, and if we didn't know it, we could look at our multiplication chart for today and look at that and say, okay, well, I know that 3 times 9 equals 27, and I am going to continue to practice my math facts until I know that by memory. And it's okay if you don't know that by memory yet. We're going to continue practicing. So 3 times 9 equals 27. Okay, we know that that's right. But here we have 9 threes and 10 threes minus how many threes? Well, let's think about this. We could do this one of two ways. We can look here and say, well, how many threes are here? We know that we have 9 threes here. And in order to get 9 threes out of 10 threes, how many would we have to subtract or take away from 10 to get 9? Okay, so you could have 1 3, and that is the correct answer. But let's say that I still had questions about this. I still didn't really understand. I know that you take away 1 from 10 to get 9. That makes sense, but I want to really see it. Well, what I could do is I could make 10 groups of 3. So I could make 10 circles. And I could put 3 circles inside of each of my circles. 3 little dots. They look like pretty little pizzas, don't they? It's making me hungry. Okay, so if I took a moment to count this, I would count by 3s. And I would get, uh-oh, my little pepperonis disappeared. How about that? What is going on? Stay, pepperonis. Okay, so if I counted these, I would ultimately get, I would be counting by 3s. So I would say, oops, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. So there's 30 groups here. There are 10 3s here. But did you notice when you counted by 3s that there was 27, and 27 would have been right here. So if we subtract, we know we want to get to 27 because we know that 3 times 9 equals 27. If we subtract this last group here, how many 3s are in there? Well, there's one group of 3, right? So you know that that is correct. Raise a quiet hand if you still don't understand, and we can make sure that you understand this so that you can keep practicing. Okay, you have done an awesome job, fabulous mathematicians, and now it's time to practice.